Yes, good afternoon students everyone. We have completed carbohydrates yesterday and now today we are going to see the next biomolecule, that is protein. What is a protein? Protein is a polymer of amino acid, isn't it? Proteins are the polymers of amino acids. That's what we are going to learn first about amino acids. Then we'll see the protein structure and all. So, what are amino acids? The name itself is going to say amino acid. What it is? Amino acid. That is the compound which is going to have carboxylic acid and amino group in its structure. Then we are going to call that one as amino acid. Understand? When we are going to have a carboxyl group and an amino group in a given compound, then we are going to call that one as amino acid. So these amino acids, how they are going to be? So this compound, if you are looking at, it is going to have a carboxyl group and it is going to have amino group. So when we are going to take an amino acid, here also we can give the configuration for that amino acid based on H and NH2 group. How we are given for a carbohydrate? It is based on H and OH group. We are given H and OH group based, we are given D and L configuration for a carbohydrate. The same way we can able to give H and NH2 group configuration of amino acid is going to decide it. So now here NH2 is going to be present on right hand side. I am going to call this one as D amino acid. If that NH2 is going to be present left hand side and hydrogen is right hand side, I will call this one as L amino acid. It is called as L amino acid. Now this D and L, which is going to be more, we can able to say it is L amino acid. Whenever we are going to see the different proteins which are available, the proteins are going to be comprises of a L amino acids in its structure. So all naturally occurring amino acids are L type. That's what you can say for the amino acid configuration. Now if you can see the classification of amino acids, we are having different types of classification. The first classification, if you want to say, based on position of amino group. If you want to classify the amino acids based on their position of amino group, we are going to have a carboxyl group present. Then adjacent carbon is called as alpha. Adjacent to alpha is called as beta. Adjacent to beta is called as gamma. Adjacent to gamma is called as delta. Like that we are going to have the trivial nomenclature. The carboxylic group adjacent carbon is called alpha. Adjacent to alpha is called beta. Adjacent to beta is called gamma. Adjacent to gamma is called as delta. So if I am having, in this case where it is alpha position, COOH, this is called alpha amino acid. Whereas here, now this is alpha, this is beta. Here if NH2 is present, this is called as beta amino acid. This is alpha, this is beta, this is gamma. This is called gamma amino acid. So like this, we can have the classification based on where the amino group is present, that is at alpha position or beta position or gamma position. So the classification, whatever you have seen here, the naturally occurring all amino acids are going to be alpha amino acids and they are of L type. L configuration and they are of alpha amino acid. That's what you are supposed to remember. Very closely asking question regarding this one is, what are the naturally occurring amino acids? They are L amino acids and also there comes under alpha amino acid. L alpha amino acids will be present in all the proteins whatever we are having in nature. This is a one classification you can see. And one more classification we can see based on number of amine and carboxyl groups. If you are taking amino acids, they are going to have one amine group, one carboxyl group, it is compulsory. When we are having some amino acids can have more than one amine group, more than one carboxyl group. If we are having more than one amine group, we are going to call them as basic amino acids. What they are going to have? One extra amine group. They will be having two amine groups and one carboxyl group. That's why they are called as basic amino acids. Lysine, arginine. They will be comes under basic amino acids. Even histidine is also comes under basic because of presence of nitrogen lone pair. Second one, if we are having one extra carboxyl group, I am going to call them as acidic amino acids. They are going to have one extra carboxyl group. The names we can able to write: aspartic acid, glutamic acid. Aspartic acid, glutamic acid. The next one is neutral amino acids. What is meant by neutral? Total we are having 20 amino acids. Out of them I have given already here 3 plus 2, 5. The remaining all amino acids, 15 amino acids. Remaining 15. Glycine, alanine, valine, isoleucine, leucine, serine, threonine, cysteine, methionine and all aromatic amino acids like tyrosine, phenylalanine, tryptophan and proline. These are all comes under the neutral amino acids. Anyway, we are supposed to learn the structures of the amino acids. That's why I am not writing all the names here. While I am writing the structures, I am going to show all 20 amino acids which we are going to study here. Is it fine? This is a classification based on position of amino group. This is a classification based on number of amino groups and carboxyl groups. Amino groups we are having more than one. Then we are going to call them as basic amino acids, lysine, arginine and histidine. And acidic amino acids where we are having more than one carboxyl group, aspartic acid, glutamic acid. And neutral amino acids, they are going to be remaining 15 amino acids out of 20 standard amino acids. This is what the classification we are having for the amino acids. Now we are having one more important classification. We will see. Next classification, just I am going to give you based on the structure. First one, simple amino acids. I am writing A dot A for the amino acid. simple amino acid if you are taking, we are going to get 2. That is always this is common. Any amino acid, this is common. COOH, CH and H2 is common. Now here whatever you are having, that is going to be changing. That's why this is common. For any amino acid, this is going to be common group. And if I am having here hydrogen, what is this one? Glycine. It's going to be glycine. We can able to write 3-letter code GLY and single letter code G. This is glycine. So this is common, and we are going to have here CH3. There you are having simple hydrogen, here I am having simple CH3. This is called as alanine, ALA, single letter code A. These are all comes under simple amino acids. They are simple amino acids. Second one, branched chain amino acids. We are going to have branched chain amino acids. CHCOOH NH2 is common. I am going to have CH, CH3, CH3. What is this one? Isopropyl group will be present. We are going to have isopropyl group. So this is called as valine. VAL. V. VAL. V will be the single letter code. Then we are going to have this is common. Next we are going to have CH2, CH, CH3, CH3. We are going to have isobutyl group. We are going to have isobutyl group. It's called as leucine, LEUL. It's called as LEUL. And next we are having so this is secondary butyl group. It is called secondary butyl. Just the CH3 is going to be get transferred from here to here. That isomer. That's it is called as isoleucine. It's called as isoleucine I. Understand? So these are simple amino acids. These are branched chain amino acids we are going to have. And next we are going to have hydroxy. Side chain with hydroxy group we are going to have here. CHCOOH NH2 is common, and here I am having CH2OH. Here I am having CH2OH. This is called serine, SERS. Here I am having CH3 CHOH, which is called as threonine. So this is going to be present. We are going to call it as threonine T. So which is going to be present along with your hydroxyl group amino acid. And next one, sulfur containing amino acid. Sulfur containing amino acids. So we are going to have CH2SH, thioalcohol. We are going to have we are called as methyl mercapto. So many times they are asking, sometimes based on what functional group, what is a R is going to be present in an amino acid, it is comes under methyl mercaptan, or we are going to call it as thioalcohol, methyl thiol. So what is this one? Cysteine. Here we are supposed to taking care of writing the name. Cysteine is going to be T-E-I-N-E. If you are writing cysteine, C-E-S-T-I-N-E, E if you are missing it, it's going to be dimer of this one. That's why be careful while writing the spelling also here. Cysteine then is going to have CH2SH. Next we are going to have thioether is going to be present. So this is called as methionine. Cysteine, methionine, these two are comes under sulfur containing amino acids. And next one, extra NH2 containing. Extra NH2 containing or basic amino acid what you have seen already. Here if you can take NH2, CH2 4 times, CHCOH, NH2, which is called as lysine, LYSL. CH2 thrice, NH2, C double bond NH, NH. This is called very important group. It's a guanidino group. It's a called guanidino group. Gamma guanidino group is going to be present. This amino acid name is arginine. ARG, and we are going to give R. We are going to give R for this one. And here the lysine is going to be K. Sorry, here this is K, not L. And next one, aromatic amino acids. Here I am going to write the first one. This is called histidine. When we are going to take histidine, it is going to be comes under both basic amino acid and it is also comes under aromatic amino acid because of this imidazole ring. We are going to call this one as imidazole ring. This imidazole ring is going to be aromatic. That's why it can be called as aromatic amino acid. Whereas it's going to have one extra nitrogen which is going to be giving you a basic character. That's why it can be included in basic amino acid. That's why I can able to write both of them here. And next one. Phenylalanine. This is alanine. This is going to be phenyl. So that's why it is phenylalanine. PHEF we are going to write. Just we are adding one OH group to the benzene ring. It's called as tyrosine. This is indole group. This is called as tryptophan. TRPW. This is going to be tryptophan. TRPW will be the name of this tryptophan compound. Okay. And next one. Acidic amino acids. This is called aspartic acid. ASPD. This is glutamic acid. GLU. It's E. Next one. Amide amino acids. Just it is derivatives of glutamic acid and aspartic acid. And if you are instead of COOH, you are having CO and H2. This is called aspargine. It's with N. And glutamic acid is getting converted to glutamine. The last one, cyclic amino acid. Proline, PROP. So this is what we are having, the amino acids, all standard amino acid. I think you might able to get bored up by looking at all the structures what I have drawn, but I am doing this one for making you that we can able to by heart all the structures. That is only the purpose I made it live now. Otherwise I would have drawn all the structures on the board, then I can able to explain them. But we can able to memorize if you are having a proper mindset for by hearting those structures. Simple way to remember them is going to be their side chains. It is based on side chains we are going to be remembering them. This is the common group we are having in every amino acid. This is glycine, GLY, G, and it is alanine, ALA, A. These two are having a simple side chain, H and CH3. That's why I can able to call them as simple amino acids. And next we are going to have, what is the name of this one? Methyl group. It is going to be methyl group and hydrogen in case of glycine and alanine. When we are going to take branched chain amino acids, we are going to have three here. One is valine, VAL, V. It is going to have isopropyl. It's a branched chain is going to be present as a side chain. That's what it is called as branched chain amino acid. Valine, VAL, V. And this one is leucine. It is going to have, what is this one called? Isobutyl. It is isopropyl. It is isobutyl, which is going to have leucine, LEU and L. These are the three-letter code, single letter code we are going to give for amino acids. I think we are well aware of this one in your genetic code. Next one, isoleucine is an isomer of leucine. It is going to have secondary butyl as a side chain, ILEI. And coming to the hydroxyl group amino acids, we are going to have serine, threonine. They are going to have thioalcohol, and it is also having alcoholic group is going to be present. Here it is primary alcohol, and it is going to be secondary alcohol is going to be present. Then we are going to have serine, threonine. The next one is sulfur containing amino acid, where we can have thioalcohol, CH2SH, thiol. Methyl thiol is going to be present as a side chain. CES, we are having TEINE. I already said we are supposed to taking care of spelling of this cysteine, where you are going to have CYS, TEINE. If at all your E is missing, it's a dimer. CYS, TINE if you are writing, it's a dimer of cysteine. So that is not going to be happen for your sulfur containing amino acid. So that's why it is very important of this spelling. Methionine is going to be one more amino acid which is going to have sulfur. It is called as thioether. Thioether is going to have in this methionine, that is MET and M. That is the one we are going to have. Now the next one, if you can see, NH2 containing, that is extra amino group is present in a given amino acid. Here I can have epsilon amino group I can call. Alpha, beta, gamma, delta, then epsilon. We are going to have CH2, 4 times NH2 will be side chain here, and it is going to have lysine, LYS, That is a single letter code. We are not supposed to have confusion for a single letter code. For LEU, we are having L. But LYS, we are supposed to have alternative, that's why we are giving K. Till now, whatever you have seen, the first letter of that amino acid is going to be a code. G, G, A, like that we are having. But from here, we are going to have a bit difference. LYS, I can't use L again, I am using K here. Next one, arginine is very important one. The highest basic group in your organic chemistry is guanidino group. That the guanidino group is going to be present for arginine, that side is going to be highly basic amino acid. Which is strong basic among lysine and arginine? If the question comes, it's arginine because of guanidino group. Then aromatic amino acid, I said already, histidine is going to be comes under both. That is going to be comes under basic amino acid due to the presence of NH, which is able to accept one more electron pair, that is going to be giving that because of this lone pair, it can be acting as a basic amino acid. And imidazole ring, we are going to call this one as imidazole. This ring is called imidazole. This imidazole ring is going to be aromatic. That's why it can be included in aromatic amino acids. And next one is phenylalanine. Up to here it is aniline. and we are having one benzene ring. When benzene is acting in a substituent, we are going to use phenyl. That's why it is phenylalanine PHEF. Here also we are not using P, we are using F. And then tyrosine, it is going to be T, we can't use Y. Just it is hydroxybenzyl. This is benzyl group is present. Here hydroxybenzyl is going to be present. It is hydroxybenzyl. This entire thing I can consider as side chain. It's benzyl. It is hydroxybenzyl. And if you are coming this one, it is going to be indole ring. We are going to call this one as indole. This methyl indole ring is going to be present. That is going to be one more aromatic amino acid. Tryptophan, TRPW will be the single letter code. Then coming to the acidic amino acids, which are going to have extra carboxyl group in structure, they will be called as acidic amino acid. Aspartic acid, ASP, D, we are going to use. And glutamic acid, and we are having one more CH2 is increased. That's it, we are having the difference. One more CH2 is going to be the difference. Other than that, nothing is there. And this is going to be glutamic acid, GLUE. And next, amide. Yes, they are derivatives of carboxyl group. That's why they are derivatives of glutamic acid and aspartic acid. Aspartic acid derivative is aspargine, ASN, and glutamic acid derivative is glutamin, GLNQ. That is what you are having. And last and important one is going to be cyclic amino acid. This can also be called as amino acid. This can also be called as amino. Why? Because it is not having amine group, it is going to have NH amine group. It's called as proline, PROP. That is what we are having single letter code. Just count all 20 amino acids came or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 standard amino acids are going to be present in your naturally occurring proteins. All these 20 amino acids. I said no after these 5, these 2 and these 2 and this one if you are taking, remaining all are having one NH2 group and one COOH group. That's why they will be comes under neutral amino acids, you can call them. These are comes under basic and acidic amino acids. Okay, so this is based on the structure. All structures are important. They can able to ask us what will be the side chain in a given amino acid or what will be happens when it is going to be. Recently, the JEE papers they are asking how many lone pairs of electrons present in a given compound. For that purpose also we are supposed to know the structure of amino acid. Just remember them. Okay, just if you are having a proper mindset to remember, then obviously we can remember anything. That is depend on our mindset. Okay, try to keep all the structures in your mind, then so that we can able to answer any questions they are going to ask from this area. And next one, we can see polar, non-polar. Amino acids can be polar, non-polar. How can you classify the amino acids as polar, non-polar? If we are having any polar group, we are going to call them as polar amino acid. If they are not having any polar group, we are going to call them as non-polar. And polar, they can have charge. Some of them are not having charge. Polarity can be positively charged or negatively charged, and even neutral polar also we are having. So that's amino acids. If we can able to know the structures, you can able to identify what they are. If you are taking all these 5 amino acids, they are non-polar. Why? Because hydrocarbon side chains are there. Hydrocarbons all are non-polar. That's why they will never be getting polarity. These are all comes under non-polar amino acids. This one is having CH2OH. Oxygen is going to have polarity, but there is no charge development on this. That's why it is going to be comes under neutral polar amino acid. Here also the same thing, CH3CHOH. It is also developing polarity but not charge. That's what it becomes under. And SH also having polar group, and CH2S. This is not going to have polarity because of sulfur without having any hydrogen on it. And here if you are taking NH2 and guanidino group, these are comes under positively charged. Why? Because we are going to have NH3 plus, NH3 plus. Here we are going to get positively charged one. That's why they will be comes under positively charged polar. And whereas here, this one also will comes under the same thing. And the tyrosine is having OH group. That's why it can be considered polar neutral. And these two are non-polar. Acidic amino acids are going to be, H plus is going to be comes out so that we will get negative charge. So that's why they are negatively charged polar. And these amides if you are taking, they are going to have CO and H2 polar group, but neutral, they are polar neutral amino acid. This is going to be having non-polar problem. So if we are having the structure idea, we can able to decide whether they are going to be polar or non-polar. If it is polar, whether it is positively charged polar, negatively charged polar or neutral polar. Understand? These are the questions you can able to get it from the amino acid structures. And one more classification I am going to give for the amino acid. It is based on the essentiality. Based on essentiality. Say for example, if any amino acid we are not able to take, what is going to happen? They will cause the deficiency. If amino acid is not there, that particular protein can't be synthesized. If protein is not going to be synthesized, then we will be getting some defect. So protein deficiency, obviously Kwashiorkor defect we are going to call. So there is a chance of getting. So what is the amino acid which is important for us? What is the amino acid which is not important? Anything such like that is there? It is not like important and not important. It is based on the synthesis or not synthesized. That is, whether our body can able to synthesize the amino acid from a source which we are having in our body, and the amino acid which can't be synthesized in our body should be supplied through diet. If you are supposed to supply through diet, we are supposed to call them as essential amino acids. If no need to supply through diet, we can able to synthesize in our body, then they are called as non-essential. It is not meaning of we require or not require. It is based on whether you are supposed to supply through diet or not supposed to supply through diet. If you are supposed to supply through diet, we are going to call them as essential amino acids. If you are not supposed to supply, we are going to call them as non-essential amino acids. We are having 10 essential, 10 non-essential. 10 essential, 10 non-essential. So why I am writing here only this one? To remember this code. Mat will fly. This is going to be a code for essential amino acids. What is MATTVILPHLY? Some are going to be a single letter codes, some are we have to remember them. M is methionine. So same one we are going to have. It is methionine. This is arginine. This is not alanine. This is not alanine. This is arginine. And this T is going to be threonine only. What we are having here, threonine. And this T will be tryptophan. This T will be tryptophan. VIL same only. Valine, leucine, isoleucine. Valine, isoleucine, and leucine. No problem. So this P is phenylalanine, that is not proline, histidine and lysine. So certain are going to be a single letter codes, but certain things we are supposed to remember them. But easy to remember, mat will fly, PHLY, that is going to be essential. Other than these 10 amino acids, remaining 10 amino acids are comes under non-essential. They have to supply through diet. The other 10 amino acid no need to supply through diet. That is what we are able to say from this classification. Essential, non-essential. Essential amino acids are those amino acids which has to supply through diet. Their mat will fly. This is how we can remember these amino acids. So that's about the classification of amino acids which we are having. And the next what we are going to have, the important points which you are supposed to remember in the examination point of view for amino acid is first one, isoelectric point. What is isoelectric point? The pH at which the amino acid is going to be existing in Zwitter ion. It is going to be existing in Zwitter ion. So the two terms I have used here, isoelectric point and amino acid which is present in Zwitter ionic form. This is what we have seen, the amino acid. This amino acid is going to have amine group which is acting as a Lewis base, and this is the carboxylic acid which is going to be protic donor. Now, whereas we are having both groups present on the same. Now, from the carboxyl group, the H plus is going to be get dissociated, and this H plus is going to be attacking on your NH2 group. So, what is going to be present here? CH, COO minus, and NH2 is going to be present in the form of NH3 plus. This R side chain, whatever it is, all neutral amino acids which are going to have one amine group, one carboxyl group, they are going to be present in a salt form. They are going to be present in salt form. What is this now? It's an acid, it's a base. The acid is going to be reacting with your base and it is going to form the salt. Now this is going to have both positive charge and negative charge, which I am going to call it as Zwitter ion or inner salt, or we can call it as inner salt. The same compound is going to be get reacting and forming the salt. That's it is going to be called as inner salt or Zwitter ion. So now what the definition I am giving? The pH at which the compound is going to be existing in Zwitter ion, that pH is called as isoelectric point. So this pH is called as isoelectric point. The pH at which the substance is existing, the amino acid is existing in a Zwitter ionic form, that pH is called as isoelectric point. Now this isoelectric point, usually it ranges from 5.5 to 6.3 in case of amino acid. Where it is neutral amino acid we are talking about, where we are not having extra amine group and extra carboxyl group, there we can have the pA value will be ranges from 5.5 to 6.3. That is going to be a pA for the neutral amino acids. So if we are having the pH is going to be maintained 5.5 to 6.3, that compound is existing in Zwitter ionic form. Say for example, I am maintaining pH greater than Pi. If pH is greater than Pi, what is going to be happen now? Greater than Pi means already it is 6.3. You can say greater than 6.3, greater than 7. It is going to be basic pH. In basic pH, what is going to be happen? OH minus ion is going to be present. That OH minus ion is going to take out the H plus from your NH3 plus, and it is going to be get converted to NH2 CH COO minus R. What we are going to call this one as anion. It is going to be called as anion. So above the Pi, the amino acid is going to be behaving as anion because of the OH minus is going to take up the proton on NH3 plus and it is going to behave as anion. As it is anion, where it will move? This is the question we are going to get usually. The pH greater than Pi, the amino acid going to move towards which electrode? Which electrode is going to move? It is going to move towards the anode. Suppose if you are making the pH lesser than Pi, if you are making pH lesser than Pi, what is going to happen lesser than Pi? Almost it is acidic. We are going to get H plus. Now the Zwitter ion going to have CO minus. That CO minus is also going to be get reacted with H plus, and we are going to get NH3 plus. CH COOH R. Now here I am positive charge, it's going to be called as cation. The cation will move towards cathode. So these are the questions we can able to get it from this particular point. What it is? Zwitterium is a compound where we are having both positive charge and negative charge, which is also called as inner salt. And then we are going to take the pH at which it is going to be existing in zwitterionic form is called as isoelectric point, Pi. The Pi is going to be usually for neutral amino acid, it is 5.5 to 6.3. If it is above the Pi, the pH was maintained, it is nothing but basic pH when you are going to. That basic pH is going to have OH minus. That OH minus is going to take up the H plus from the NH3 plus, and now we are going to have anion existing. That's why when we are having pH above the Pi, the amino acid is acting as anion. That's why it is moving towards the anode. When it is below the Pi, they are going to have acidic pH. That H plus is going to be combined with CO minus, so that it is going to behave as a cation. That cation is moving towards the cathode. When we are going to take Pi, there is no movement. It is not moving anywhere. It's not having any movement. No movement of ion is going to take place. At Pi, the amino acids are having less solubility, so that we can able to separate them. At Pi, the amino acids when we are going to take. Understand this particular point when we are going to get isoelectric point. These are the points you are supposed to remember them. Fine. How to calculate Pi for any amino acid? Say for example, the CO minus is there and H3 plus is there. Whenever you are going to calculate, this is going to be considered as Ka1. This is considered as Ka2. So now, if you want to get Pi, it is going to be given by pKa1 plus pKa2 by 2 is going to give you the isoelectric point. Why? Because when it's called as double titration. First of all, you are titrating with a base, and then you are going to titrate with a acid. Then we are going to get two different endpoints. The two different endpoints are nothing but one is because of CO minus group, one is because of NH3 plus group. So that we are going to get pKa1 value, pKa2 value. Average of this one is nothing but isoelectric point. When they are asking, they will be giving value of Ka1 and Ka2. From that you can calculate the Pi. So these are the points you are supposed to remember. When we are going to have the other amino acids like basic or acidic, they will not have the Pi value like this. For basic amino acids is more, for acidic amino acids is less because of the presence of extra amine group and extra acidic group. Okay, this is regarding isoelectric point. I hope everyone can understand. Next important point is optical activity. I think we are aware of optical activity. What is optical activity? When we are going to have a chiral carbon in a given compound, then it is going to rotate the plane polarized monochromatic light either to the right or left is called optically active. If you are going to see, all your amino acids are going to have optical activity. Why? Because they are having chiral carbon. First itself I said D amino acid, L amino acid, it is there for everything except glycine. Except glycine. Why? There is no chiral carbon. For everything it is going to be different, but for glycine only it is having two sides hydrogen. That's why it is not going to show optical activity. Except glycine, remaining all amino acids are optically active. At least you can have one D, one L. Which amino acid is going to show more number of optical isomers? It is isoleucine, which is going to have two chiral carbons. Isoleucine is going to have two chiral carbons. That's why it is going to show 2 per 2, 4 optical isomers are possible for your isoleucine molecule. So these are the things you are supposed to know for optical activity concern. Glycine is not optically active. Isolation is showing the more number of chiral carbons, so more number of optical isomers. And then how we are going to identify them? Ninhydrin test. Ninhydrin test is going to be the identification test for amino acids. All amino acids are going to give purple color. All give purple color. But proline will give yellow color. Proline will give yellow color. That's the difference. All amino acids are going to be purple color with ninhydrin. That is the identification for the amino acids. And the proline is only giving yellow color because of amino group or secondary amine. Amine or secondary amine group, we are going to have the proline is going to show yellow color with ninhydrin, whereas remaining all amino acids are showing the purple color. This is what the way we can able to identify amino acids. That's why even when we are going to have the touch, then we will have this color. It is because of our hand is going to be full of amino acids only. Okay. And the next one, xanthoprotic test. Just remember the names. I am not going to explain in detail about them. It is for aromatic amino acids. It is just nothing. HNO3 we are going to get. Xanthoprotic test. Milan's test is going to be separating your tyrosine from the remaining ones. Just this remember, aromatic amino acids are going to be identified by xanthoprotic test and Milan's test. Ninhydrin is a common identification test for all the amino acids we are having. Understand? So these are the amino acid practical organic chemistry based questions we are going to get. The ninhydrin is the identification, just remember it. And the xanthoprotic test is going to be aromatic amino acid, and Milan's test is going to be comes under tyrosine, a separate test we are going to get from this one. So these are the points we can able to remember about the amino acids. The amino acids, what we discussed here, it is alpha amino acids are comes under L type, will be the naturally occurring amino acids. All amino acids are going to be optically active. We have seen the classification of amino acids based on their polarity, based on the presence of amino group position, based on number of amine group and carboxyl groups, and based on their structure. And very important one is which of the following is essential amino acid, which of the following is non-essential amino acid. That is the one so many times asked question. Just have a look over all the things. I have given shortcut also for that one. Mat will fly. The mat will fly is going to be essential. The remaining 10 amino acids are going to be non-essential. And then we discussed about isoelectric point and their optical activity. When we are going to take optical activity, except glycine, remaining all are going to be optically active because of at least one chiral carbon present at amine group presenting carbon. And the other one we discussed is the two chiral carbons are going to be present in isoleucine, so that it is going to have more number of optical isomers. That is 2 per 2, 4 optical isomers. And we have seen isoelectric point, and there we discussed about where it will move. Anion is going to be present above the PA, cation is going to be present below the PA, so that towards cathode below the PA, above the PA it is going to be towards the anode, and at PA we are not going to have any movement, that is going to be having settled down as a salt. These are the things we are supposed to remember in case of amino acids. Then how these amino acids are going to be acting as building blocks for your proteins, and after getting construction of protein, how that protein is going to get structure, primary, secondary, tertiary and quaternary. Those things we can see tomorrow class. I hope everyone can understand. And the next we will be having the interaction I already said. Just go through the material what we have uploaded. What we have uploaded the material, just go through them, solve the questions, And once if you are solving the question, then only you are going to get the doubts. You can ask us during the interaction, then you can improve your subject. But the listening to the video is okay, fine, but rather than this listening, we are supposed to practice so many number of questions, then you are going to get the doubts. If you are asking us, just we can have discussion on that, then you will be able to improve your subject toward that particular topic. Okay, thank you everyone. Tomorrow we'll see the protein structure.